All right, in this video, we're going to be looking at higher degree trigonometric equations. So not just linear equations, but other types of equations. So one thing that I, again, like to do is a substitution. In this case, if we were to rewrite this notation, it would look a little something like this, right? With the sine alpha being squared. And so I might say something like, let x equal sine alpha, so that I'm looking at 2x squared minus 1 equals 0. Well, now it just becomes a problem where I'm solving a quadratic. I'm going to do this with square root property. And so I get that x must be equal to plus or minus 1 over the square root of 2. I do get the square root of both of these, but the square root of 1 is 1. So I have plus or minus 1 over the square root of 2. Now remember, x is equal to sine alpha. So really what I want is, where is the sine of alpha on this domain equal to plus or minus 1 over the square root of 2? And that's at all the pi over 4s inside our quadrants. So that means that alpha is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Oh, circling that, ended up doing the cross out the other one. Okay, let's try this again. So this time I have a theta. Again, I could rewrite this as 2 cosine theta squared plus 3 cosine theta minus 1 equals 0. And let's let x then be equal to cosine theta. That means I have 2x squared plus 3x minus 1 equals 0. I can't solve this one with square root property. I do have to factor. And I need this to be a positive 3, so I'm going to have a positive, nope. This actually isn't factorable. There isn't any combination of -1 and +1. My pen's not wanting to work. There we go. -1 and +1. There isn't any combination. So back to the drawing board. I'm going to need to use quadratic formula. So that would be x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I have 9 plus 8 all over 4. And so I need to then have that cosine of theta needs to be equal to -3 plus or minus the square root of 17 over 4. And I'm going to have to use my arc cosine, but then I'm going to have to come back to my domain as well. So let's just do this first one. Theta is equal to the arc cosine of -3 plus the square root of 17 all over 4. And I'm going to use Desmos. There we go. All right, so I get 1.286. Now remember, that is in radians. I also want to find this in the negative. Okay, undefined. So I'm not even going to worry about that. That's probably because that's probably a number smaller than -1. So I just have this here. That's in radians. 1.286. And remember, pi is 3.14, and so pi over 2 would be bigger than that. So this is in quadrant 1. And cosine is also going to be this positive number on our domain. Now, if this was just, this is where it gets a little bit tricky. If it was just this, we'd be good, but it's this, right? And we said, oh, well, it can't be the negative because that's not in cosine's range. So it's really just this, but I am looking on theta to be between 0 and 2 pi. So I have one of them in quadrant 1, but I also need to find it in quadrant 4 to get that same answer. Well, whatever this is in radians, 1.286, it would just be a reflection down here in radians. And so that would be whatever 2 pi minus 1.286 is. And so that's going to be our 2 theta measurements for this here. Now you would have to have a calculator in order to find that. And depending on what the rounding would be, that's what you would do. But let's look at one that you do have to do some factoring and you don't need a calculator for. All right, so again, I'm going to rewrite this as 2 sine theta squared plus that sine theta equals 0. And so I'm going to say let x be equal to sine theta. So I'm really looking at 2x squared plus x equals 0. And let's factor out an x. So I have 2x plus 1. And so solving this, I would say, well, then x is equal to 0 and 2x plus 1 is equal to 0. Well, then I'm looking at sine theta being equal to 0 and 2 sine theta plus 1 being equal to 0. Now, am I including my bounds? I am. Okay. So sine theta being equal to 0, there's a couple ways we can think about this. One is in the rectangular coordinate plane. So that's going to happen at 0, pi, and 2 pi. The other is in the unit circle, reminding ourselves that sine is our y value. So that's going to happen here, here, and back again when we get here. If I solve for sine theta, here I get negative 1/2. Again, rectangular wise, that's going to happen twice. But I really don't know from that graph what those numbers are. So let's go ahead and pull that into the unit circle. I need opposite over hypotenuse to be 1/2. So that must happen at 7 pi over 6 and 11 pi over 6. And so those would be my 5 solutions for this. And one thing you can also do in Desmos is you can also go in and check your answer. So we could say like, okay, where is 2 sine squared x plus sine x? Where is that equal to 0 from on this domain, right? Because there's 2 pi. And so that's at 0, pi, 7 pi over 6, 11 pi over 6, and 2 pi. So that's one way you could check your answer as well to make sure that you have all of the solutions algebraically in your problem.